Yeah, for question 42, the first part of the question asks for what would be the random variables. So the random variables are the earnings of the first 10 random variables x1 to x10 are the earnings of the player 1 in evenings 1 to 10, and the next 6 random variables y1 to y6 are the earnings of player 2 in the evenings 1 to 6. The first 10 are IID random variables, and the second 6 are also IID random variables, and these two sets of random variables are independent of one another. What is the mean and the standard deviation of the total winnings made by all in the classmates? So the total winnings made by all is the sum of these 16 random variables. So what we do is we consider the expected value of the total winnings made by the first player, the expected value of the total winnings made by the second player, and add them together to give the final answer. This is the total winnings made by all 16 random variables. What about the standard deviation? The standard deviation is the square root of variance, which is the square root of the variance of the total winnings made, which is the square root of the variance of the total winnings made by the first player by the variance of the total winnings made by the second player, which is 10 times 100 square plus 6 times 100 square, which is finally we get the answer 4 times 100. Find the mean and standard deviation of the difference. For the difference we consider x, actually it should be x minus y. So it should be expected value of x minus y, which is expected value of x minus expected value of y, which is equal to 10 times 300 minus 6 times 300, which is 4 times 300. And what was the other question? Find the mean and standard deviation. Okay, standard deviation of the difference. So standard deviation of x minus y is the square root of variance of x minus y is equal to square root of variance of x plus negative 1 square variance of y, which is square root of variance of x plus variance of y, which is square root of variance of x plus variance of y, which is equal to what we had done earlier, which is 400. And for the part D, what assumption would be affected? We could no longer assume that the random variables are independent. In this case, the independence assumption would be affected.